Hello guys, now this is one interesting problem on relative velocity. Okay, it is really interesting because there is something called upstream and downstream, and something has been released there. Now what is that? Let us see. Speed of a motor launch in still water, it is 7 meter per second, and speed of the stream is 3 meter per second. Okay, speed of launch is 7 meter per second in still water, but then speed of this stream is 3 meter per second. When the launch began traveling upstream, a float was dropped from it. The launch traveled 4.2 kilometer upstream, turned about, and caught up with the float. So what is actually happening here? The launch is traveling upstream first. Okay, that is number one. But then before just when it started its upstream journey, it dropped a float there. Okay, so so we are saying upstream, correct? The stream is moving in this direction. Okay, and this is that launch or boat, whatever you say here. Its speed in still water, okay, that is 7 meter per second, and speed of stream is 3 meter per second. Speed of stream is 3 meter per second in the west, and this is this launch is moving in this direction, is moving upstream. All right, now listen carefully. When it started its journey from, let us say, this point A, it drops this float, correct? It is dropping this float F, and then it is moving upstream. Okay, how much distance did it cover? It covered 4.2 kilometer and then came back. Okay, so now let us say this distance, okay, from here to here, it is 4.2 kilometer, that is 4200 meter, correct? Now when this launch reached this point B here, what would happen to the float? Would it remain over there? It will not. It will move with the speed of stream there, that is 3 meter per second. Now listen, the speed of launch in still water is 7, okay, but then upstream speed would be 7 minus 3, so upstream speed would be 4 meter per second, correct? Then how much time would it require? So time would be equal to distance upon speed. So distance is 4200 upon speed. Speed is 4. So how much is that? 1050 second. Correct? This is my time, let us say T1. Okay. Now by the time my launch reaches 4200 meter, my float would move how much distance on this side? Let us find that out. Now speed would be 3 meter per second. So distance moved by float is equal to, that would be the speed multiplied by time. So how much is the time? 1050 into 3, correct? So that would be 3150 meter, correct? Now what is the total distance then? Now from here, now my launch is going to turn about. Okay, now see, my float is still moving with the stream, okay, with a speed of 3 meter per second. My downstream speed for launch is going to be how much? It is 7 meter per second is still water. Okay, still water speed is 7 meter per second, and now it is assisted by the stream speed, so it would be 7 plus 3. But ultimately what would be the relative speed. So this is moving with 7 plus 3, that is 10, and that is moving with 3. So resultant speed downstream, it is going to be equal to 7, correct? So my downstream speed, that is the speed with its own speed. Downstream relative speed is going to be equal to 7 meter per second. And then how much is the distance that needs to be covered? That would be 3150 plus 4200. So distance would be 3150 plus 4200, that would be equal to 7350, and then 7350 divided by the speed. Therefore time is equal to time t2, okay, time taken from here to catching the float would be equal to 7350 divided by 7, that would be equal to 1050 again second, correct? So then, now what is the question? Question is, how long is it before the launch reaches the float? Okay, so now launch has started its upstream journey. It reached that point B there, and then turned about, and and then it caught up with the float. Okay, so the total time would be time taken to cover 4200 meter and back, right? So then total time taken, I am writing time taken is equal to 1050 plus 1050, that is equal to 2100 seconds, correct? So that is how we would be dealing with relative velocity problems in motion in one dimension. Of course, we are again going to get relative velocity. We are going to come across relative velocity when that would be in motion in plane. Okay, till then, bye bye, thank you.